Hello everybody, welcome back to my channel and welcome to a brand new crash course. In this crash course we are going to be covering Docker, and you need absolutely no prior knowledge to take this crash course. We are going to cover it from 0 to 100 as usual. So by the end of it you're going to have a great understanding of what Docker is and how to use it in your applications. Now to get started, I highly suggest to go to my GitHub page at Harblaith Docker Crash Course. And as you can see here, I misspelled crash by accident. It was just a quick typo. But essentially, what we have here are 3 projects right here. And these are the projects that we are going to be working with in this crash course. So you can either go ahead and clone this repo or you can fork it as well. So you can kind of do either or, but these are the projects that I am going to be using. So if you want to follow along, you can go right ahead and clone this. At the moment of the recording, it is private, but it will be public as soon as this video is published. Alright, so this is all you have to do to get started. Again, you can be a complete beginner, and I hopefully by the end you will really have a great understanding of what Docker is. I really put a lot of effort in this crash course, and I went really detailed with diagrams and everything of that nature. So let's not kind of prolong the inevitable. Let's get into the crash course. Okay, so let's answer the question of what is Docker? Now, I can explain Docker to you from a technical standpoint, but I think it might be a better idea to introduce Docker to you by looking at a real-life scenario of something that simulates what Docker is doing with our software applications. So that's the approach that I'm going to take, and hopefully it pays dividends by giving you a clear idea of what Docker ultimately is. So let's take this approach. So on the screen here, I have a bunch of tests. So these abbreviations here are just abbreviations for a bunch of tests that undergraduate students would take to get into graduate schools of their choosing. For instance, over here we have the medical school admission test. So this is a test that you have to take to get into medical school. Over here, this is the DAT, which is a test that you have to take to get into dental school. This is the GMAT, which is a test that you have to take to get into MBA school. And then over here, this is the LSAT. So this is the test that you have to take to get into law school. So these are very, very important tests. And let's say in this scenario that you were in charge of running these tests. So basically you were in charge of the test center that runs these tests over here. Now, because these tests are so important, I mean, we're creating future doctors, future dentists, future businesswomen and men, and future lawyers. These tests are so important. Essentially, what you want to do is you want to minimize the amount of cheating that occurs. So how do you do that? Well, from prior experience, you realize that the most amount of cheating occurs when you allow testers to bring their own utilities to these tests. For instance, let's say for the MCAT you need a sharpener, eraser, and a pencil. You basically tell the individual, hey, bring a sharpener, eraser, and a pencil. Now the problem with this approach is those individuals can kind of alter those utilities in some way that can kind of help them write that test and help them, well, cheat on the test. For instance, maybe a tester would just bring in an eraser, and then inside of that eraser has some sort of piece of paper hidden inside of it that kind of can give him answers to the MCAT. Well, to circumvent this, what you decide to do is, well, hey, buddy, you don't bring anything. Instead, what I am going to do is I'm going to create a list for every single test. And then inside that list, I'm going to create all the utilities that is needed to successfully write this test. So let's go about doing that right now. So for the MCAT, let's say that that list is made up of pencil, eraser, and sharpener. And then for the DAT, we got the pencil, eraser, sharpener, and protractor. And then over here, we have for the GMAT, pencil, eraser, sharpener, calculator. And then for the LSAT, we have the pen. So you basically wrote a list of all the utilities that is needed to successfully write a particular test. Now, what you do is on the test day, you basically kind of take this list and you generate a box. So from this list, you generate and you build out a box. So you built out a box of all the utilities kind of inside of this list. So for the MCAT, you're like, well, pencil, eraser, sharpener. Okay, well, you go to your kind of inventory and you grab a pencil. So you grab a pencil and then you grab an eraser and then you also grab a sharpener. And you basically put it into this box over here. And now you do the same thing for the DAT. So you get pencil, eraser, sharpener, but you also get a protractor. So let's put that protractor in there. And now for the GMAT, well, you get a pencil, eraser, and a sharpener, as well as a calculator. So you put that calculator in there. And then lastly, for the LSAT, you look at your list and you generate a box that contains a pen. So on the test day, you built out these boxes based on the list that you created. Now, when a tester comes, you figure out what test they're taking first. So let's say this tester is taking the MCAT. You go to the MCAT, and then essentially you create kind of a replica of this box over here. So you create a replica of this box, and you give it to the tester. So you give it to the tester, and then you basically tell the tester that, hey, well, you got everything that you need to write this MCAT. This is everything that you need. You got nothing more. You got nothing less. So go ahead and write the MCAT. Well, you can kind of go over here and you can see, well, now he can go write the MCAT. Now, let's say we get another tester and they're like, well, I'm here to write the GMAT. Well, you create kind of a duplication of this box over here. And then you give it to that tester. And then, basically, you're like, go write the GMAT. So now he, based from this box, is actually writing the GMAT. And lastly, let's go over here. And then let's say, well, I'm here to write, let's say also the MCAT. Well, you can generate another box. So because they're here to write the MCAT, well, you go over here, you generate another box. And you're like, well, here you go. You got everything you need to write the MCAT. Well, let's go over here. And now this individual is writing the MCAT. Okay, so awesome. I hope this makes sense. But you might be wondering, what in the world does this have to do with Docker? Well, this scenario that we ultimately created over here is actually very similar to what Docker will be doing with our software applications. So let's kind of just quickly go over what we did. So we have a bunch of tests. For each test, we wrote a file that basically contains the instructions of everything that is needed to successfully write this test. So we just created a kind of a list of instructions over here. Now on the test day, we used this list to kind of build this box over here. So we built this box over here. And then whenever a tester came, we created a duplicate of this box. We gave it to the tester, and now the tester is able to successfully write the test that they intend to take. Now, let's kind of look at what Docker is doing. So instead of tests, Docker is going to be dealing with applications. So for instance, it might be dealing with a Node application or a Django application, some sort of software application. So let's actually change this to Node. So we'll change this to Node. Now, over here, what we can do in some sort of file in Docker, we can write down a bunch of instructions that is needed to generate this thing over here. So over here in this file, we're going to have a bunch of instructions that contain all the information that is needed to generate this box. Now inside of a Node application, we might need things like an operating system. We need certain dependencies, certain files. All that information is going to be contained in this file over here. Now, the next step is, well, we can generate this box over here using this file. So essentially now we have this kind of box that contains everything that is needed to run our Node application. However, when we want to run this application, we create an instance of this box. So this box initially isn't running. This box isn't running, but when we want to run our application, we just create an instance of this box. So just like over here, this box was kind of just like a demo box. This box wasn't used to write a test. Only once we gave it to the tester was it basically kind of a functional box, and it was actually being used for something. We create kind of this box over here, and then when we want to run our Node application, well, we basically kind of duplicate it, and then we create an instance of our Node application. And that ultimately is what Docker is trying to achieve. So let's actually kind of talk a little bit about the terminology. So again, instead of tests with Docker, we're dealing with applications. So it can be any sort of application, a Node application, a Django application, a PHP, Laravel application, it doesn't matter. Some sort of application. And we are going to write down in this file the set of instructions that is needed to build basically a kind of a box that contains everything that is needed to run that application. Now over here, this file in Docker is known as a Dockerfile. So this is known as a Dockerfile. So let's actually write that down. So this is known as a Dockerfile. Now we use this Dockerfile to generate this over here. Again, this is not a running instance of our Node application. This is basically something that contains everything that is needed to run this application, but it doesn't actually run the application itself. Now this in Docker is known as an image. So this is known as an image. Now, whenever we want to actually run the application, well, we use the image to create kind of an instance of it, and then that ends up being the kind of running application. Now, this right here, this instance of an image is known as a container. So is known over here as a container. So that right there is Docker in a nutshell. We are creating Docker files, which we use to build images, which allow us to run containers. And that right there is Docker in a nutshell. Now, let's actually look at an example of basically, when we would actually use this in an application. So let's say we have 3 Node applications. Now they all use Node, but they might use different dependencies. So for instance, Node app 1 might use Express. Similarly with Node app 2, it uses Express, but Node app 3 uses Apollo Koa. And then Node app 1, well, it uses Mongoose because it interacts with a MongoDB database. Node app 2 uses Sequelize, and then Node app 3 uses TypeOrm, which allows it to basically communicate with a SQL database, but with TypeScript. So as you can see here, we have a bunch of different dependencies for this particular application. So what we can do for each application, we can write a Docker file specifying, hey, these are the things that are needed to run this application. And then we can use this Docker file to build an image. So we build an image of that application. So let's put that as yellow. And then basically we can use that image to spin up as many running instances of this application. So then we can basically spin up as many as we want. It could be 1, but then it could be, 100 if we want. So we can do that as well. Now we can do the exact same thing with this thing. So we would just have a different Docker file, and then we would then generate an image, and then we can use that image to spin up as many instances of this application that we want to run. And we would run these inside of containers. So that right there is Docker. I hope that kind of gives you a clear idea of what Docker is. But you might be asking, well, why in the world do I even care about doing this? If let's say you've come from a Node background, if you want to run a Node app, all you really have to do is an npm install and then an npm start or something of that nature. Well, why would I want to go through all this trouble to just simply run my application? Well, there's actually a very, very good reason why you want to kind of run your application in this way. And we're going to get to that in the next section. By now, you might have a clear idea of what Docker is and what it is ultimately trying to achieve. But you might be asking yourself, well, why? Why do I care about running this application inside of this container? It seems like a lot of work. Why can't I just run my applications the way that I've usually been running them? Just install all the dependencies and run some sort of start script. Why do I care about writing a Docker file, building an image, and then running these applications inside of these containers? This seems like a lot of work. Well, there's actually a lot of benefits that come along with running your application in this way. And we're going to see all those benefits throughout this crash course. But in this lecture, I'm going to highlight some of the main three. So let's begin with the first one. So the first one is, it makes running our application super easy, especially when working with teams. Now, if you go back here, it actually seems like it makes running our application a lot harder. Now remember, previously before, all we had to do is install all the dependencies and just run some sort of start script. Now we have to create a Docker file with all the instructions. From that Docker file, we have to build an image. And then from that image, we basically run these containers. That seems like a lot more work. That does not seem easier at all. Well, to understand how it really makes things easier, we really have to understand the container itself. So remember, the container itself is a completely isolated environment. It contains everything that is needed to run this application inside of, well, this container. So it is completely independent of what is installed or not installed in kind of our computer or our operating system. So now that we know this, let's actually kind of see how that can really be helpful when running applications. So let's say over here we have this Django application. And a Django application is simply a framework that is built on top of Python. So you absolutely need Python somewhere in your system to install or to run this Django application. So let's say you go about trying to, you clone this repo and you want to run this Django application and it ends up failing. And the reason why it fails is because you don't have Python installed in your computer. Now you can see here that basically running this application is dependent on basically what is installed in your computer. Now you can see that this dependency can get pretty annoying. Now you can just simply say, well, whatever, I can just install Python, but maybe there's a project that needs multiple dependencies that are not installed in your application, and that can get pretty annoying very, very quickly. So again, without Docker, basically the application is dependent on what's installed in your kind of operating system in this scenario. Now, what you can do in kind of a more Docker approach, well, why can't I just spin up a container that contains everything that is needed to run this Django application? So within that container, we are going to have Python, and that container is going to be completely isolated from our computer. So it's not going to care what we have in our computer, whether we have Python or whether we don't have Python. So that is kind of one example, and kind of a similar example. Let's say there's a Django application that needs Python version 3, but you only have Python version 2. Well, in this case, this dependency is going to cause this Django application to fail. Now with Docker, what we can do is we can just spin up a container that's going to contain everything that is needed to run this application, and that is going to include the correct version of Python. So you can see that that can get a lot easier. Now to really highlight how Docker can be super, super effective, let's look at this application, or kind of this scenario over here. Let's say we have two applications. A Django app that absolutely needs Python 2 to run. And then over here, this is another app that absolutely needs Python 3 to run. So this app can't run with Python 3, and this app can't run with Python 2. And let's say our computer, we only have Python 3 installed. Well, if we want to run this application, well, we would have to downgrade to Python 2. and now we would be able to run this application. But then let's say we need to switch back to this application. Well, now all of a sudden we have to upgrade back up to Python 3. And this kind of flip-flopping back and forth between Python versions in our computer can get really, really annoying. So again, what's a better approach? Well, we can use Docker. Whenever we need to run this application, we can spin up a container that contains, again, everything that is needed to run this application, and that is going to include Python version 2. Now, whenever we need to run this application, well, we would spin up a container that contains everything that is needed to run this container, or this application, and that is going to include Python version 3. And now it's actually possible to run both applications at the same time, because we can just run one container and then another container. And remember, these containers are isolated. They're completely isolated from one another, and it's not going to be dependent on our operating system. So that's how it actually makes running applications super, super easy. But that's just for you. Imagine how much easier it's going to make running applications when working with teams. So let's say I have a Node application here that absolutely needs Node version 14 to run. And let's say I have a group of 4 developers that are working on this application. However, one individual has Node version 9 installed. Another individual has Node version 11 installed. Another individual has 12, and then let's say myself, I have 14. Well, this Node application is not going to run for these 3 individuals. And you know what? It might take time to troubleshoot it, but ultimately we might figure out that, hey, you don't have Node version 14 installed. Well, instead, to kind of circumvent this, again, we can just create a Dockerfile, build an image, and then for each individual say, hey, build that image and then run a container off that image. And that image is going to have, or that container is going to contain everything that is needed to run that application, completely independent of basically the Node version that you have. So that's kind of one scenario. Also, there's another scenario where some applications actually struggle to run in certain operating systems. For instance, let's say we have a Node app that runs well in Linux and Mac but struggles with Windows. Now, let's say half of our developers are using Windows. Well, half of our developers are going to have a hard time running this Node application. Well, again, if we spin up a container, it's going to be completely independent from everything, including the operating system. The container is actually going to contain its own operating system within it. So now we can run this application easily without kind of the struggle of Windows, Mac, or Linux, whatever operating system it kind of struggles with. We don't have to worry about that because now we're running our container completely independent from any outside environment. So that is one benefit. Let's talk about another benefit. So another benefit is it produces a very similar development and production environment. And this is kind of similar to what was going on over here. Let's say we have a application. So this is a Node application, and we're running this application in development. And this is kind of the non-Docker approach. And let's say this Node application absolutely requires, Node version 14. And that's okay because in development, we have Node version 14. So we're able to run this in development. Now let's say we basically kind of push this to production. And by pushing it to production, we have some sort of virtual machine. And we basically put all the files and everything that is needed to run this application. Or we basically put the files of this Node app into this virtual machine. However, maybe this virtual machine doesn't have Node version 14. Maybe it has Node version 13. And so this virtual machine over here in the production environment won't be able to run this Node application. So you can see here kind of this, we can actually get kind of different environments in production and development. And that's ideally not what we want to do. With Docker, all we have to do is, in development, we have an image. And we say, I want to spin up a container of that image. And again, it's going to contain everything that is needed to run basically the application that the image is associated with. in production, we can do the exact same thing. We basically can give whatever server, whatever virtual machine, an image and say, well, okay, run a container based on that image. And because we're using the same image, the container is going to be completely the same in development and production. So this is another benefit. Another benefit that I'm going to talk about is it really integrates well with a continuous integration and continuous delivery practices. So continuous integration, continuous delivery is just basically kind of a practice where you can essentially integrate your code into a central repo, and then it kind of follows a certain pipeline that leads to production over here, that leads to you kind of deploying your changes to a production server. So, something can happen. So we can have basically a central code base over here, and maybe we created some sort of change. Now with Docker, what we can do is we can really integrate Docker well with kind of continuous integration, continuous delivery practices. So let's say we can create a pipeline using Docker that ultimately first tests our code. So we can spin up a container that is solely responsible to testing our code. So we can test our code. And then once basically all the tests pass in this container, what we can do is we can spin up a container that basically runs our application. So this is kind of the built container. And then we can push that container into our production server. And this will lead to, updates in our production application. So this very, very easily integrates well with kind of this really important continuous integration and continuous delivery practices. So those are some of the 3 benefits that I see fit, that are very important, and you don't really get without kind of having a Docker approach. We're going to see a lot more benefits, but I hope that kind of clears your mind as to why we would prefer to use Docker over other approaches. I'll see you guys in the next section. Okay, so that is enough about the theory of Docker. Let's talk about how we can install Docker on our local machine. Now, doing this is really going to be dependent on your operating system. If you are on Mac, well, you are very, very lucky because the installation process is really, really easy. If you're on Windows, it's a little bit more complicated, but I'm going to guide you through it nonetheless. So if you are on Mac, go ahead and continue watching. If you are on a Windows device, then, well, please move ahead to the Windows. Linux is pretty much the same thing with Mac, so you can follow along here if you want to. So just go to docker.com, and then once you go to docker.com, click on Get Started. And then over here, you can see Docker Desktop, and that is exactly what we want to install. So you can see here, we got the download for Windows, download for Linux. If you're on Linux, download this. But if you're on Mac, well, press this button. And then once you press this button, you should see docker.dmg. I have Docker 1 because I've done this installation before. No problem there. Let's just quickly wait for this installation to go through. Hopefully this doesn't take too long. It absolutely took very long, so I went ahead and I paused the video. So once this is done installing, you can quickly click on it. And then you can see here that it's doing a little bit more installation, so I might have to pause the video for this as well. So once this is done, I will be right back. Okay, so once that installed, you basically get this option over here. So essentially what you can do is you can either drag the Docker into your applications folder, or you can drag it to your local desktop. At this point, it is pretty much installed. I'm not going to drag it anywhere because, well, I already have it installed. As you can see, it's over here. But if you don't, go ahead and just drag it either to your applications folder or your desktop. So I'm going to go press X, and this kind of installer over here, I'm just going to shove it in the trash. I don't need it. Now, to kind of double check that you have Docker, what you could do is you can go to your terminal. So let's go, hopefully my terminal opens up a little quickly. There we go. So you can go to the terminal. Let me increase the size of this just so it can look a little easier on the eyes. So all we can do now is we can just do something like Docker version. And if you get a specific version when you do Docker version, this might take a while on my end because I'm running a lot of things. There we go. So you get a Docker. If you get a Docker version, well, now you have Docker successfully installed, which is great. So if you're on Mac and Linux, this was the video for you. In the next section, I'm going to be talking how we can do it for Windows. So unfortunately, if you are on Windows, the steps that we have to take are a little bit... So unfortunately, if you are on Windows, we have to take a little bit more steps to install Docker Desktop. Now, to see the steps, what we can do is we can go to Developers, and then we can go to Docs. And then in here, we can see the download and install documentation. And then we want to see the documentation for Docker Desktop for Windows. And over here, we can see some of the documentation and the prerequisites. So you can see here, if we want to install Docker Desktop, there are some system requirements. Now, if you are on Windows 10 Pro, Enterprise, or Education, which I'm assuming most of you won't be, the installation process is going to be relatively easy. Now, if you are on this system right here, Windows 10 Pro, Enterprise, or Education, all you have to do is make sure that you have Hyper-V and Container Windows enabled. This is all you have to do. Now, how do you do this? Well, very easily. You can quickly do a quick Google search, and you will see here how to install Hyper-V on Windows 10. And basically, essentially, over here, this is saying the only thing that you have to do is run this command on PowerShell as an administrator. So basically, to open up PowerShell, all you have to do is go to that search button and then write PowerShell. Now, once you see Windows PowerShell, don't click on it right away. What you need to do is you need to right click on it and then click on Run as Administrator. And then you should basically see this shell over here, and you can see here now that you're running it as an administrator. So simply just go ahead and copy and paste this command right in there, and therefore once you do that, you should have all of the requirements to download Docker Desktop. Now, if you want to download Docker Desktop, then all you can do is you can just go here, download from Docker Hub, and you can just say get Docker. Now, I'm on a Mac. Unfortunately, I can't really showcase this because I do not have a Windows machine, but that's the step that you're going to take if you have Docker 10 Pro, Enterprise, or Education. Now, most people are going to be kind of in this category. They have Docker 10 Home. And so here we have a different set of instructions. Now, these set of instructions are still very, very easy. There's just more things that we have to do. So you can see here that these are our system requirements. So we need to have Windows 10 or higher. Now, if we don't have Windows 10, unfortunately, you guys won't be able to really work with Docker. You might have to use Docker Toolbox, which is a really legacy version. So I hope you are on Windows 10. And so here we can see some other kind of requirements. And so let's see here. So over here we need this enable WSL2 feature on Windows. Now, this is a relatively kind of a nuanced or a relatively involved thing to do. Over here, we can refer to the Microsoft documentation to see exactly what we have to do. I'm just going to quickly go back, but you can click on that. I have it over here opened in another tab. So essentially what we have to do is we have to follow these steps over here. Now, similarly, we have to open PowerShell as an administrator. Remember how we do that. These steps over here, right PowerShell, right click on that, click on Run as an administrator. And then in here, all you have to do is just a bunch of copying and pasting. Unfortunately, it's going to be a little bit more than one command. So we're going to have to do this command over here. Step 2 is okay. Don't worry about it. There's nothing really going on there. This is what we have to write for step 3. So go ahead and then after you write that, write this command. And then what we want to do is we want to download a Linux kernel. So essentially, this is a relatively involved command. So you can just basically press this right over here. And then we have to write this on PowerShell. And then lastly, we have to install a Linux distribution from our Microsoft Store. You can choose Ubuntu if you want. That's the latest version. And so once that is done, and again, this is a relatively kind of a larger step. Once that is done, you can simply then go download from Docker Hub and then just say get Docker. And there we go. You should have Docker installed by then. Unfortunately, I can't really show you because I do not have a Windows machine. So I hope this kind of my instructions were worthwhile. And basically, once you have that installed, all you have to do is just say Docker. And you should see a version in there or some sort of other command if you just said Docker. If you want to see the version, it would be docker-v. As you can see here, I have a bunch of commands that relate to Docker, so I know I have Docker installed. You can also do Docker or docker-v. So that is how you install it for Windows 10. I'm assuming most people have Windows 10 devices. Again, if you don't have Windows 10, then you're going to have to use a relatively legacy version known as Docker Toolbox. So you can go in here and just kind of check out the documentation for how to install Docker Toolbox. It's also not a crazy difficult. It's just not as nice to work with, unfortunately. So that is how we do the installations. So once we are done the installations, let's actually move on to Dockerizing our applications. So I'll see you then. So now that we have successfully installed Docker onto our machine, let's go about actually containerizing and Dockerizing our first application. Now the first application that we will Dockerize can be located inside of this repo. So you can just go to my username and go to this repo right here, Docker Crash Course. At the moment, this repo is private, but it will be public once this course is published. Now, if you want to follow along in this lecture, inside of this repo, once you cloned it, you can go to O1 building an image. And in here, you will see two folders. You will see the start folder, and then you will see the final folder. The start folder is going to be the base folder that I am going to start off with as well. So over here, all you can see is an index.js. And then the final folder is going to be basically the folder that contains everything once we are kind of done with the start folder. So if you want to follow along, please go ahead, clone this repo, and go into this directory right over here. So I have this folder all set up right now, and I'm in my start directory. And all you can see, really all I have here is a index.js file and a package.json. So let's focus on the index.js file. Over here, inside our index.js file, we have a very simple Node Express application. Now a quick disclaimer, you do not need to know Node if you want to follow along with this course. I am going to use Node throughout the course, but again, what I am going to be doing is not really focusing on the code, but I'm going to focus on how we can get this code running in a container, in this isolated environment. And the steps we take to do that are going to be very, very similar, whether it is a Python application, Django application, PHP application, C# application is going to be very, very similar. So again, I'm not going to be dwelling on the code. I'm going to be dwelling on how I can get this application running in a container. Now, with that being said, let me just quickly explain what this file is doing. So over here, I am basically getting kind of an outside dependency. So I'm getting Axios, and I'm also getting Express. So I'm getting Axios and Express. So Express is a framework built on top of Node, and Axios is basically an easy way that we can make HTTP requests. So over here, I'm basically instantiating app as Axios, and then over here, I am performing a GET request at the /route. And at this GET request, what I'm doing is I am basically fetching and basically I'm using this Unsplash API to fetch some random image URL. And once I fetch this random image URL, I am sending it off to the browser inside of this image tag. And now over here, I'm basically listening on a particular port. In our case, I said port 3333. So let's actually quickly run this in kind of a non-Docker way, and then we'll figure out how we can do it in a Docker fashion inside of a container, of course. So to do this, the first thing that we have to do is we have to install all of the dependencies. So in this case, the dependencies that we're using is Axios and Express. And this is all located right over here in our package.json. We have, Axios and Express as a dependency. So all we have to really do is just do a quick npm install. And now once we do that npm install, I realize that I am in the root directory. Let me quickly move to the actual directory that we're using, so the start directory. Let's do just a quick npm install. And once we do that, we should get our dependencies inside of a node module. Awesome. And now all we have to do is run some sort of start script. So in our package.json, we can just say start, and then we can say node index.js. This is basically the start script to run a particular node file. So now I can do npm run start. So I can run this application and I get this console.log. Cool. We are running on port 3333. So now if I go to that port, so let's do localhost 3333. And there we go. I get this random image. Now if I make this request again, I get another random image. If I make this request again, I get another random image. If I get this request again, ooh, this is really cool. Wow, that's really nice. And then if we can make this request again, I can get another random image. All right, so this application is working. However, again, we are running it locally in basically our environment. Now, if we didn't have Node installed, then this application wouldn't work at all. So let's actually go about trying to run this application in a container. Now, remember, what are the steps that we have to take to Dockerize our application? Well, we have this Node application. And the first step that we have to take is we have to write a Docker file. So we have to write this Docker file. And then once we write this Docker file, we have to build an image. And once we build that image, we can basically run an instance of that image known as a container. So once we have this image, we can run our containers. Now in this lecture, we are going to focus on the Docker file. We are going to create this Docker file. So let's actually go about doing that right now. So to create the Docker file in the start directory, in the root directory, you create a new file and well, you call this file Dockerfile. And as you can see, this is a unique name because now we have kind of this icon over here. Now, I'm going to go ahead and write out the instructions. So I'm going to write out all of the instructions, every kind of configuration in this Docker file. And I'm going to do it all at once. And I'm not really going to explain what's going on. But once I write it, in the next sections, I'm going to go line by line explaining exactly what's going on. So don't be worried. But right now, I'm just going to write out the Docker file that allows us to create an image for this particular application. So the first thing that we are going to write is from node alpine. So from node alpine, and then we are going to do workdir, and that's going to be /user/app. And then we are going to do copy ... And then we are going to do a run npm install. And then we are going to do cmd. And then we're going to do npm run start. So this is the Docker file that is needed to create the image that will ultimately allow us to run our application. So if this doesn't make any sense to you, well, no worries. We are going to dissect every single line in great detail in the next few sections. So I'll see you then, where we are going to explain what this line is doing right here. Well, my friends, in the last section, we created this Docker file, which will allow us to create an image for this particular application over here. In the next few sections, we are going to dissect every single line in this Docker file so we can have a better understanding of what exactly is going on here. Now, one thing I want to say is that this Docker file is responsible, well, for building an image. And every single line here is going to contribute to that fact in some way. So if we look at a diagram over here, we can say, for the sake of this example, that we start off with a completely blank image. Now, once we go about executing this line over here, well, this image becomes less blank. So we can say that maybe, hey, we get some new files and folders within this image. And then, well, once we execute this line, well, this image now becomes even less blank. We update it some more. And then, let's say we execute this line, then the image gets updated some more. So now maybe there's another file and folder in there. And then we execute this line, and then, well, we update our image some more, and then we execute this last line, and then we update it basically to the image that we ultimately want to receive. Basically the ultimate image for this application over here. So let's go about explaining exactly what is going on, and we are going to start with this command right over here. So what is this command? For node alpine. What does this mean? Well, when we say from node alpine, essentially what we are trying to say is we want to specify a base image. So let's go back over here. We basically don't want to start from scratch. We want to start off with some sort of base image with files and folders and dependencies within it. Now, which one do we choose? Well, the base image that we choose is going to be dependent on the application that we are going to run. So for instance, here we are running a node application. So what we are going to want is some sort of node base image. And this is going to contain kind of everything that is needed to run a node application. Now, if we were running a Python application, well, the base image that we are going to use is probably some sort of Python base image. Now, how do you know which base image you want to use? Well, you can go to Docker Hub. Now, Docker Hub is a central repository for a bunch of images. So you can see here, there's a bunch of different images inside of this repository. So we have a Java image, we have SQL, we got Mongo, we got Postgres, we have Ubuntu, we have BusyBox, we have Node. So Node right here is an image inside of Docker Hub. And basically what we can say is, well, we want to use this image as our base image because it contains all of the kind of directory, all of the utilities and all the kind of the packages that are needed to run a node application. So that is basically what is going on there. So by specifying from node, we're basically going to get an image that contains everything that is needed to run a node application. So for instance, we are going to get, well, node itself. So we can go over here and we are going to get, well, node itself. And we might get some other things like, well, npm. npm is very important. That's associated to node. We also might get things like git, and we might get some other things, but I'm just going to put these three over here. So these are kind of the things that we are going to start off with, which is super cool because, well, we're running a node application. I suppose we should probably start off with a base image that is associated with node. And that way we can basically use all of these utilities to run our application. All right, so that makes sense, I hope. Now again, if you are running a non-node application, let's say that you're running a Django application. Well, you can probably go over here to explore, and maybe you can search for a Python node, a Python image. So over here, as you can see, there is a Python image. So instead of something like from node, you would say something like from Python. And we can basically use any image that is located here in this Docker Hub kind of repository. And if you're not too familiar with Docker Hub, don't worry all too much. We'll talk about that in extensive detail later in the crash course, but you can kind of think of it as the GitHub for images. And we can basically use any image that is publicly posted in this repository. Now in this case, we are going to use Node, and we are going to use Node Alpine. Now, so far, I guess this makes sense, but what does this mean over here? What does this dash alpine mean? Well, over here, we can actually specify any type of version of this particular base image that we want to use. So let's actually go back to Node. And we can see here some of the different versions that we have. For instance, let's say we absolutely needed to use version 15.7.0. Well, we can use this tag over here. And this tag, again, will specify the version. So basically, you can take a look at whatever version is needed. You can actually click on them and kind of read them in detail and see exactly what's going on. But you can basically specify the version with this tag over here. Now, what is this alpine version? Well, this alpine version is kind of known to be kind of the absolute bare bones. So we don't get anything more, anything extra. We just get the absolute bare bone to run our Node application. So we get very, very little, which is pretty good because it makes it lightweight. And this is why I like to kind of specify alpine with basically any kind of image, because we kind of get just the bare minimum. We don't get any extra configuration. So for instance, because we specified alpine, well, we probably might not get Git with that because we don't really need Git to install to run our Node application, but we do need Node and npm. So that is why I like to have the alpine tag. But let's say you do require additional things, that maybe it would be better for you to use something that is not a alpine version. So if you actually scroll over here, you can see, well, here you can do Node version, or you can do something like Node version alpine. And then basically what this means is, well, over here you're getting extra configuration and extra files. Here for that particular version, you are getting the absolute bare minimum. Now, alpine itself, I believe, is associated with one of these. Let's see, alpine. I'm trying to find alpine itself. It's associated with a particular version, but again, it is basically getting the bare bone of something. Alpine right here. So it's associated with version 15, but again, it allows us to just get the bare bone. So I hope that makes sense. The first line, the from node alpine, allows us to specify our base image, so we can basically get some of the packages and utilities that are needed to run our Node application. So that is that. Let's talk about these two in the next section. So now that we have a good understanding of what this command is doing, let's explore what these two commands are doing over here. So let's take a look at our current image. Basically, inside of this image, we have the bare bone implementation to run a Node application. We have Node, we have npm, and we might have some other files and folders associated to running a Node app. But right now, inside of our image, we have nothing specific, no folders and files specific to our current application over here. For instance, well, we have an index.js file, and this is basically kind of the root of our specific application. So if we want to run this application in the container, we are probably going to need to somehow get this index.js file and get this package lock.json and get this package.json and these node modules into our image, because, well, these are important files and folders that are needed to run our specific Node application. Well, we actually accomplished that with the copy dot command. So essentially, the copy command, what it's doing is it's going to copy something in our current project folders into the image itself. Now, what does this dot mean? Well, the dot basically specifies the working directory of our current project. And we are saying that we want to use kind of the root working directory. And we can specify this working directory when we build the image. But over here, we're saying that we want the root. And usually the root is basically the files and folders where the Docker file lies. So right here, you can see here the Docker file lies here. So we're saying that we want to copy everything inside of this directory, everything inside of this over here. So the node modules, the Docker file itself, the index.js, the package.json, and then the package lock.json. So we want to copy everything in there into the working directory of the container. Now, if we don't modify it at all, the working directory of the container will be the root of the container. So it's going to be inside along with npm and node. So let's actually go about doing that right now. So let's just ignore this line over here for a second. So we're just going to do a copy. Remember, copy, we're getting the basically everything inside of the root of our application, essentially where the Docker file lies. And then we're putting it inside basically the root level of this image. So let's go about quickly doing that right now. So we're going to copy the node module, the Docker file, the index.js, the package lock.json, and the package.json. So we're going to copy those in there. So let's change the color of this. So over here, we're going to basically copy the index.js. And then we are going to copy the node modules. And then we're going to, I believe we got a few more to go. So we're going to copy the Docker file. We're also going to copy the package.json. And then we are going to copy the package-lock.json. And so with this copy command, what we did was we copied everything that is needed to run this specific application into our image. So now we have node, npm, and all the files and folders needed to run our application. And we accomplished that with, well, the copy.copy command. Now, what we did here is probably not the best approach, and let me tell you why. Let's say we have some sort of folder inside of our application. Let's say we have a lib folder, and inside of this lib folder we have certain JavaScript files or whatever files inside of this folder, and we decide to copy this into the root directory right over here. Well, it's highly likely, very highly likely, that inside of this image already there is some folder called lib. It's very highly likely that, our node base image contains some sort of folder in it called lib. Now, if we decide to basically copy everything in our root directory into the root directory of this image, and we also have a folder called lib, essentially what ends up happening is we override the lib container that was already there, or the lib folder that was already there. And now we just lost probably some very important functionality that might be needed to run this image, and we can get a lot of errors this way. So instead of copying everything in the root directory, what we do is we specify a working directory right over here. And we basically say that, hey, when I say dot over here, I want you to put it inside of this working directory. And we specify it with, well, I have it right over here with workdir, and then basically the path inside of the container that we want to basically place all of our files and folders in. So over here we're saying, well, you know what, I don't want to put this in the working directory. Let's actually put our lib back over here. We'll delete it a little bit later, but let's say we put our lib back over here. We're saying, okay, well, I don't want to put all these files and folders inside of the root directory because, well, we might clash with some sort of with other folders and files. Instead, what I'm going to do is I am going to have another folder called the /app/user. I believe it was /user/app folder, and I'm going to put basically all of these things inside of this directory right over here. So inside of this directory, and then I'm going to put this directory over here. And then that way, basically what ends up happening is, well, we don't get any of the clashes, which is terrific, which is exactly what we want. So this is a much, much better practice than just shooting everything in the root directory. Because if your application ends up getting very big, it's very, very likely that you will get clashes. So over here, we specify the work directory, and then we basically over here we're copying everything in a kind of our root directory over here, and we're copying it into the working directory inside of the image that we specified. Now, if the image doesn't contain basically a /user/app folder, it will generate it in this working directory. So that is it. Basically what this is doing is we are just saying that we want to get the files and folders inside of our application into some sort of directory inside of the image. And this is of course very important because, well, we need these files to run this specific Node application. So that is that. I hope that makes sense, and we will move on to this line in the next section. So far, we have created an image that looks a little something like this. We have all of the packages and files and folders associated with our base image over here. And then we have all the files and folders and packages associated to our application in this working directory that we specified. And we accomplished all this with these 3 lines of code right over here. So I hope these lines make sense. In this section, we are going to talk about this over here. And to understand what this is doing, let's look back at our image. And specifically, let's look back at this folder. How do we get this folder into our image? Well, we got this folder into our image by, well, the copy ... command. That makes sense. It's in our root directory, and we just copied everything in that root directory into the working directory of the image. That is true. That is absolutely true. However, let's talk about what these node modules are. These are a bunch of packages that we installed in our local machine. So because we installed these in our local machine, we were able to copy them into this image. But what if for some reason, and this could be a pretty valid reason, we don't have our node modules in here. We didn't install them into our local machine. Typically, we put this in a git ignore, and what happens if somebody cloned this repo and tried to run it right away from Docker? Well, if we don't have these node modules, let's quickly delete them. If we don't have these node modules in our directory, all these steps right over here, up until the copy, we actually won't have the node modules inside of our image. And so, we would need to basically, for this step over here, we would need to do an npm install and get our node modules and then put it in there. And then, as you can see, this kind of causes a dependency, and it could cause a lot of problems. So now our image could be dependent on us installing the node modules on our local machine. And that is probably not ideal because, you know what? The image contains everything it needs to install the node modules itself. And that right there is what this command is doing. This command is basically a command telling the image to run this, and then whatever files and folders it gets, put it inside of the work dir directory. And that is what this command is for. Now, specifically, the image itself is not running. The image is a read only. It's never a running instance. So what the image actually does is the image creates a running instance of itself. And well, you guys know that is known as a container. So it creates a running instance of itself, and this running instance contains everything inside of this image. So it contains node, npm, and all these things. Of course, it still doesn't contain the node modules. But what this image will do, or what this container will do, is it is going to run this command. So it is going to run this command over here. So this is going to be an intermediate container that basically runs this command, and then any files and folders that we get from this command is going to put it in the work dir directory. And so basically this container is going to run, and once basically this is over, the npm install is over, what this image does is it takes basically the environment of this container, the end environment of this container, and it basically replaces itself with it. And well, once we basically do our npm install, we're going to have our node modules. So we're going to have these node modules as well, along with the packet lock.json. But I didn't delete that just for simplicities. So we're going to have the node modules. And then, well, let's go back over here, and now we have our node modules, which is great. And then after this container, after it's done, it basically kind of shuts off on its own. So the image creates kind of an intermediate container that runs npm install. And then after that container is done, it basically takes its environment and kind of replaces itself with that environment, and then it shuts down that container. And basically that is what this command is for. It allows us basically to get other dependencies that we need to get by running a particular script. And kind of for this reason, it might actually be a good idea to, whether we have our node modules installed or not, it might be a good idea to somehow not push them into the image and let basically the image create them with this run command. Now to do that, we can actually create something known as a .docker file. So .docker ignore file rather. And so in here, this is kind of like a git ignore. You can specify all the files and folders that we don't want copied into our image. So in this case, we can do node modules. So now if we do have our node modules installed, the docker ignore file will basically prevent the node modules to be copied into this step over here. Similarly, we might want to ignore the Docker file. So we can say, hey, ignore the Docker file, because there's really no reason for the Docker file to be inside of the image. So my apologies, the Docker file should have been in here as well. So the Docker file would have been copied in here as well. But now because we put it in our git ignore, it won't be in there. And the only reason our node modules is still in there is because, well, we didn't copy it from the copy dot. But because of the run npm install, we installed it in kind of that intermediate container, and we kind of replicated that environment into our current image, and that's why we have our node modules right in there. So I hope that makes sense. That is basically the reason for this line. So in the next section, we're going to kind of finish it off by looking at this line. Okay, so the last command that we have to talk about is this one right over here, cmd npm run start. Now if you look at this over here, this command was needed to run our application in our local environment. And this command is also going to need to be executed to run our application inside of a container that was built off of the image that we created. So basically what this command is doing is it's telling our image to store this command somewhere. So store this command somewhere inside of the image. So the command, remember, was npm run start, which is basically the command needed to run our application. And then whenever this image spins up a container, it is going to run this command, which will allow the container to basically run our application. And that, in a nutshell, is what this is trying to do. We're storing this somewhere inside of our image, and then whenever our image creates a container, whenever our image creates some sort of container that will contain all of these files, immediately what it is going to do is run npm run start. And that, in a nutshell, is going to allow us to run our application in an isolated environment. So that is what cmd npm run start is doing. And that kind of concludes our Docker file. So far, we have built out the Docker file for our application, and we've talked in great detail what each line is doing and how it is contributing to the image we are trying to build. However, as of yet, we haven't really built out our image. We've only built the Docker file, the set of instructions needed to create our image. So the next step is to basically use this Docker file to build out our image. Now, for a quick refresher, if we want to containerize an application, the first thing that we need to do is write the Docker file, the set of instructions used to create our image. And then the next step is to use this Docker file to then build our image. And this is what we are going to discuss in this lecture, how we can build an image using a Docker file. And luckily, this is very, very easy. So let's actually go about doing that right now. To do this, we go to our terminal and we make sure that we are in the same directory of the Docker file that we are trying to build. And in this case, it is the start directory. And luckily, well, we are in it right now. So now what we have to do is we have to execute this command, docker build dot. So essentially what we're doing here is we're saying, okay, with docker build, we want to build an image. With the dot, we are specifying the location of the Docker file. Now, because we are in the start directory in our terminal, and the Docker file lies in the start directory, we tell it that, hey, the Docker file is in the root directory. However, let's say if I was in another directory. So let's say I moved up a directory and now I'm in the O1 building an image directory. If I want to build an image out of this Docker file that's still in the start directory, then we would do something like docker build dash start. So we would say, well, move into the start directory because that is where the Docker file lies, and build an image from that Docker file. So that is basically kind of what that dot means, that last kind of appended dot is doing. So let's actually go back to the start directory and let's do a docker build dot. Now, with really big applications, we might end up with a lot of different images, and we need a way to kind of figure out, the difference between what image is doing what. Now, in this case, it might be easy to actually give an image a name, and we can give an image a name with the -t flag. So the -t flag over here. And then after the -t flag, we basically specify the name that we want to call this image. In this case, we are going to call it Express App. And so this is everything that we need to build out our image. So if we execute this, you can see that there's quite a bit going on. So let's actually kind of expand this a little bit. And there we go. It seems like, this worked. So let's actually take a quick look at what's going on here. So it seems as though, okay, well, we're loading up the definitions from our Docker file. We're interpreting our good ignore. Remember, we have a good ignore here. And then we are doing, okay, so this is the first step that it's doing. And it seems like it's pulling the base image from Docker Hub and putting it into the image that we were trying to create. Now, this is a relatively big process, so you can see kind of how long it's taking and how much work it's doing. And then in step 2, it's creating the worker directory, and then it's copying our files and folders into our image. And then it's doing a run npm install, as we said that this would do. And then over here, lastly, it's doing the command npm run start, but it doesn't show it over here, but I promise you it is doing it. So, okay, so therefore we have created our image, but how do we go about seeing our image that we created? Well, to do this, all we have to do is docker images. And there we go. We can see all of the images that we have created. Now, chances are you only have that one Express App image. I have a lot of images that I've been working with, especially tied to Kubernetes. But if I scroll up, I can see my Express App image. And over here, you can see that it was created about a minute ago. So there we go. If you see this, then you have successfully created your image. Now, if you have Docker Desktop, you can actually go there and see the image that you have created. So that is awesome. Now, in the next section, we are going to explore kind of the fine-tuned details of what we are seeing here, right over here, kind of all the fine-tuned details, how we can delete an image, and exactly what is going on with like the tag and the image ID. So we'll do that in the next section. So now that we have created our Express App image, let's take a look at all these columns in this table over here and explore exactly what they mean. So over here we have the repository, which is associated with the image name that we gave. This makes sense. So this over here is Express App. Now over here we have the tag, and you can see the Express App has the latest tag. Now essentially the tag is very similar to what this is doing over here. It is specifying a different version of the same image. So for instance, what we could do when we build out a Docker file, so when we built out an image, we could do something like this. We can do Express App, And then we can specify a version. So we can say version 2. And if we were to execute this, you can see that it executes really, really fast, a lot faster than the original one. And we'll talk why a little bit later. But for now, if we go to Docker images, we can basically see that Express app with that tag right over here. So essentially, we can use the tag to specify different versions of the same image. So that is what this tag is for. Now the image ID is a unique identifier for the image. So over here, this ID and this ID are exactly the same because these images are exactly the same. They just contain different versions. Now over here, you can see some of my other images. They all have unique IDs, and we can use these IDs or the image names themselves to run a container off of this image. So this is really important. Now over here we have created, and this makes absolute sense. This basically says, hey, when was this image created? In our case, this was created 40 minutes ago, but you can see some of my other images, here over here we have 3 months ago, 5 months ago, almost a year ago, which is pretty crazy. And now let's look at the last one, which is the size. This is just the size of the image in megabytes, not all too important for this crash course. Okay, so that is awesome. Now we have 2 of these versions. Let's say we want to get rid of this version right over here. So how do we go about doing that? Well, we can do this with Docker image, not images, image, and then remove. And then we specify the image that we want to remove. Now specifically, we want to remove the image with the v2 flag. So we have to specify that tag right over here. So if we execute this, you can see that it got untagged. And if we did Docker images and we scrolled all the way up, we don't see that version of our Express image anymore. And the same thing goes over here for our Docker desktop. Now let's say we also want to remove this one. Well, to do that, very easy. We do Docker image remove, and we can either do latest, but if we don't specify a tag, by default it is going to look for the latest version right over here. So if we go about doing this, it says untagged and now absolutely deleted. So if you go to Docker desktop, you can see that it is completely gone. And also, well, if we list it Docker images, we can see that we don't have our image anymore. Let's see, scroll all the way up. Yeah, we don't have our Express app image anymore. So I hope that kind of clears up how we can manipulate images. So now that we have deleted our wonderful Express app image, let's actually go about and recreate it in our terminal. So to do this, well, very easy. All you have to do is docker build --tag express app and then dot. And once we do this, we go ahead and build out our image. Now, if you notice, this build was a lot faster than the previous build, than our initial build. And there's actually quite a good reason for this. And let's actually explore that reason in a diagram. So over here, I have all of the commands that are inside of our Docker file. Now remember, each command is modifying the image that we ultimately want to build in some way. So for instance, with the from node alpine, we are basically creating an image with all of kind of the base stuff needed to run a node application. And then with this command, we are building on top of this image and adding basically additional things. So over here, we're adding our work directory. Now for this command, the copy command, we're building on top of the image above it and we're adding additional things. Again, we've discussed what all these commands do. And then over here, we're going to be building on top of this image. And then we're adding basically additional things. And then lastly, we're building on top of the image above it. And then we are completing our final image. So this is the process that goes on when we build out our image. So what is going on over here? Why was this super fast? Well, the reason for this is because we've already built this image out, and every single layer over here was stored in Docker in some way. Now, when we decided to rebuild our image, basically because we've previously built it out, all of the layers are going to be stored. Oops, this should be app with a P. All the layers are going to basically be stored in Docker. And instead of going through every single step, what it does is says, okay, well, we haven't modified our Docker file in any sort of way, so I'm just going to use basically the cached version. So instead of, again, going through this whole process and building out everything, it says, okay, this is from node alpine. We've executed this command before. It gave us an image like this, so I'm just going to use this image. And then, okay, for this command, well, we've executed this command before. Nothing has changed. We're going to use this image, and so on and so on. And that's exactly what we see here. We're basically using the cached version, the version that Docker stored somewhere in its file system. And that's why this is executing so fast. Alright, so I hope that makes a little bit of sense. Now let's actually go about and let's just change our Docker file in some way. Let's actually change the working directory to, instead of, let's say, /app/application. So something a little bigger like this. So let's actually go ahead and kind of modify our Docker file in this way. So now what we're going to do is we're going to do the exact same command. We're going to do docker build -t express app. And let's see. As you can see, oh, oops, nothing happened because I didn't save it. So now let's actually execute this again. And as you can see, okay, this is taking a little bit longer. Well, the reason for this is because we haven't cached this layer over here. We've modified this layer. We basically cached the layer where it's only /user/app, but not /user/application. And so basically what happens is, well, if we go all the way up here, let's kind of look at what's happening. Okay, it's using the cached version for the node alpine. This makes sense. Okay, so it's using this cached version. Now, for the worker, let's see what it's doing. It is not using the cached version. It's actually redoing the whole step from kind of the beginning. And you can actually see everything below it. Everything below the command that we changed is also not using the cached version. And this makes sense. And the reason for this makes sense is because, again, every single command is basically building on top of the image above it. So we basically don't want to not use, well, we don't want to not use the cached version for this and then use the cached version for this. Because then the not cached version of this would look something like user application, but then if we go about using the cached version for the copy ... then we go back to user app. So we don't want to basically use the cached version if a certain command is changed above it. Now, we use the cached version for anything that is above the, basically above the command that we changed. And the reason for this is because, well, this is always going to be consistent. So there's really no point of not using the cached version. So again, the reason why this was so fast is because we cache our results. Now, if we make any change, basically when we rebuild, we are not going to use the cache for the thing that we changed in any command that is below it. And that is exactly what we see over here. Now let's actually try to make another change. Let's actually go back to app. And let's actually rebuild this image with the app directory. Now this should be super fast because, well, we have cached everything already. We've run this command before. Now let's actually see what happens if I change something in our actual file. So let's say we change, instead of listening to port 333, I'm going to say listening to port 333 ! And let's save this and let's actually try to rebuild the image. Okay, so it seems like there's something going on here. So if we go back to our Docker file, it seems like this is taken from our cache, makes sense, and also the worker is taken from our cache, but then the copy ... is not taken from our cache. It's done from scratch. And so this is really interesting. Docker knows that with the copy ... we are essentially copying everything inside of our root directory and putting it into our image. So if we change something in our kind of root directory, in our start directory, then basically we're going to be copying something pretty different into our image. And essentially Docker is smart enough to know this, and therefore it doesn't use the cache. And so over here we use the cache, but we don't use the cache for this, we don't use the cache for this, and we don't use the cache for this. And essentially this is just a great way to ensure obviously the integrity of our images, and caching makes the build process a lot faster. Now knowing this about caching, we might actually want to restructure the way that we create our Docker file, and we are going to do that in the next section. So now that we have learned how caching is involved with building Docker images, let's actually explore a certain flaw that we have with the current setup of our Docker file. Now I can pretty much assure you, out of all of these steps over here, this one right here is going to take the longest, the run npm install. And the reason for this is because we are going to install all of the dependencies associated to our application. So if we had a relatively large application with a lot of dependencies, this step can take a really long time. So we probably want to use the cached version of this as much as possible if we haven't installed any new dependencies. However, with the current setup, what we are doing is if we modify any file or folder in the root directory, in the start directory, we are going to do a run npm install. For instance, if we go over here and we add another exclamation mark, let's say we have 5 exclamation marks, so all we're doing is changing the index.js file. We're not installing any other dependencies. We are going to, if you go back over here, well, we are modifying this line over here, and so we are not going to use the cached version of this, and then ultimately we're also not going to use the cached version of this. So we are going to run an npm install even though we only changed basically a few exclamation marks in a JS file. We didn't install any new dependencies. So basically, kind of knowing about caches, maybe we can restructure our Docker file in some way that basically if we don't install any dependencies, any new dependencies, we can kind of cache this instead of doing the whole npm install all over again. And we can actually accomplish this by having 2 copy steps. Now, remember, the npm install is going to be basically based on the package.json. Any new dependencies that are added will be added to the package.json. For instance, if we do something like npm, let me do npm install express validator. And so when we install this, I lost connection there. Let me see if I can gain, there we go, I've gained my connection. So you can see here that the package.json has changed. Now nothing else in our files have changed except for the package.json and I guess the package.lock. So we basically only want to run this npm install when our package.json has changed. And the reason for this is because this is basically in charge of installing those dependencies in our package.json. So to do this, what we could do instead is, instead of copying everything in our start directory right over here, what we can do is we can say, well, first we want to copy the package.json into basically the working directory, and if that hasn't changed, we'll use the cache version of this. And then because nothing changed here, we'll use the cache version of this as well. And then after that, we can say we'll copy everything into the working directory. And that way, we can avoid that by basically changing any kind of, changing our files here. That will avoid the unnecessary npm install. So let's actually build this out. Now keep in mind that we have changed our package.json in this case. So let's actually just quickly build this image. And in this case, we are not going to use a lot of the cached versions because now we haven't used this command before. So we don't have the cached version for this. So let's actually execute this. Now if we try to build this again, you can see how much faster it is going to be. So let's quickly just change our index.js, save it, and look how quickly it is going to be at the moment. very quick. And the reason for this is because we didn't have to do the npm install. We cached this version. However, we did obviously change the files in our kind of directory over here. So this is uncached. So this is a much better way to organize the Docker file. And then this is actually going to be the final kind of Docker file for this application. There might be a little more configuration, but this is kind of the ultimate Docker file. And I think this follows the absolute best practices. So I hope that makes sense. Now that we have created our Express app image, let's go about and run a container using this image. And doing this is very, very easy. All we have to do is go to the terminal and write docker run and then the image that we have built. In this case, it is Express app. And once we execute this, there we go. We are now running our container. And you can see this log over here, this log inside of this container was the same as the log that we saw over here. And that's kind of a way that we know that this container is running. We can also tell if this container is running by doing docker. We can do docker ps. And by doing docker ps, we see all of the running containers. So over here, there was a randomly assigned container ID. It said, okay, well, this container is from this Express image. We also have the created, the status, and then we also have kind of just a randomly assigned name that Docker gave it. We can also see our image right over here on Docker desktop. So we can actually click on it and we can see all of the commands that were run. So you can see it ran npm run start, which was associated with node index.js, and then it console.logged listening on port 3333 exclamation mark, exclamation mark, exclamation mark. So that is awesome. We are running our container. We are running this application in this isolated environment. And that right there is what Docker is all about. So now let's say we want to, shut down this image. Well, to do this, we can go back to the terminal and do a Control-C. Now, once we do a Control-C, we can do a Docker PS. And you can see here that nothing is running. Docker PS only shows running containers. And if you go to Docker Desktop, well, you can see here that it has exited out. Now, it still exists, but it has exited out. Now, to remove it completely, what we could do is just go and do docker remove and then the name of the container that we want to remove. And there we go. It is removed. So now if we go to Docker Desktop, it is completely gone. Now, the way that we ran our container is kind of not the best approach because it is attached to the terminal. It has taken up the terminal. Remember, when we ran it, it took up the terminal and we couldn't really execute any commands. The best way to do it is to actually run the container in the background detached from the terminal. And we can do this with the -d flag. So instead of doing docker run express app, what we can do is docker run -d, indicating that we want it to be detached, and then we can have an Express app. And furthermore, we can actually give this container a name, just like we can give our images a name. To do this, we can do --name, and then let's call this, Express container. So essentially what we're doing here is we want to run a container that is detached from our terminal, and we want to call this container Express container, and at the end over here we want to use the Express app image. So if we execute this, there we go. It is completely detached at the moment. And if we go over here, you can see that our container is running. And you can see it is called Express container, and it doesn't have a random name. And if we do a docker ps, we can pretty much get the same information, except we, of course, can see the container ID. All right, awesome. So we know how to remove a container. We can remove a container with docker remove, and we can either use the container name or the container ID. So we talked about this, but what if we want to kind of go back? We want to stop it, just like we did before, but not remove it. Well, there's a few commands that we can execute. We can either execute docker stop, and then the container name or the container ID. In this case, I'll use the container ID because it's right there. So we can do docker stop, or we can do docker kill. And ultimately, it's going to basically stop the container. So let's just do docker kill. And then over here, you can see that our container is not running anymore. So what is the difference between docker stop and docker kill? Well, let's actually look at a diagram. They're very, very similar. At the end of the day, they're going to shut down a container that we specify, as you can see. So with docker kill, we kind of do that right away. We don't do any kind of cleanup process. We just have a container, you say docker kill, we just shut it down right away. However, with docker stop, well, we have our container and we might have kind of a little bit of a lag because we might do a little bit of cleaning up and then we stop the container. And so that's the difference between docker stop and docker kill. And depending on your application, you might want to use one over the other. And that is pretty much that. We have figured out how to run a container in our application, which is terrific. So far, we have built out this container. It was running, but then we ultimately killed it, so you can see that it is exited. So we can actually run up this container again, either by pressing the start button, or in our terminal, we can do docker start, and then either the container ID or the container name. I will use the container name because I can remember that. In this case, it is express container. And once you execute this, you can actually go back over here and you will see that your container is running. Also, you can do a docker ps and you can see all the running containers in our computer, and you can see here our express container is running. Okay, so this is terrific. Let's actually go back here and let's just click onto it. And you can see here in the logs we have listening on port 3333. However, when we go to this port, let's see what we get. Let's see if we get our application, our random image application. We don't get it. And there's actually a very good reason why this site cannot be reached. So let's look at a quick diagram. So this is a diagram. Now remember, the container is completely isolated from our machine, and the container contains multiple ports. Now the application is running on port 3333 inside of our container and not our local machine. However, at this point, when we make a request to localhost 3333, what our browser is going to do is it's going to basically make a request and look into the port inside of our machine. And at the moment, port 3333 is not running. So that is why we're not getting anything. So somehow what we have to do is we have to do a little bit of port mapping. We have to basically say, okay, when we need to listen on port 3333, we need to basically forward this request to port 3333 inside of the container. And again, this is known as port mapping. Essentially, when we make a sort of request to a specific port in our local machine, we forward that to another port in the running container. And we do this when we execute the run command. So let's actually go about doing that right now. So the first thing that I want to do is I want to completely remove this container. Now to do this, I can't just do a docker remove express container. And the reason for this is because it is running. So as you can see here, it says you cannot remove a running container. So the first thing that we have to do is docker stop or kill that container. I'm going to use the ID for this. So we can do docker stop that container. And then we can do a docker remove that stopped container. So now we can remove it. Awesome. So now let's rerun this container. So we're going to do the simple command. So docker run, and then we're going to do express app. We're going to run this in detach mode, and we're going to give it the same name of express container. But now we also want to add kind of that port mapping, and we can do that with the -p flag. And so the first port is going to be 3333, and then colon 3333. So essentially, the first port over here is specifying the port in our local machine, and then the other port is the port inside of the container we are trying to create. So essentially, by specifying this, what we are saying is whenever we make a request to port 3333, we want to forward it from our local machine to our container. And that right there is port mapping in a nutshell. So now if we execute this, so let's execute this command. Now you can see that the container is running great. And if we go to localhost 3333, give it some time, there we go. We can see our application. Terrific. Welcome back everybody to a brand new project. So we are now done with O1 building an image, and now I want you guys to move to O2 working with volumes. As you can imagine, this section is going to be devoted to, well, working with this concept known as volumes. So if you don't know what that is, don't worry, I am going to explain it in great detail throughout this part of the crash course. So as usual, inside the working with volumes, I have a final directory and a start directory. So go into the start directory, and if you actually go into it, you will notice that this is a React application. Now you do not need to know React to take this crash course. It is completely fine. I'm going to be using React to kind of explain the concept of volumes, but you can use all these concepts with whatever application you are working with, whether it's a front-end, back-end, Django, PHP, MySQL application, it doesn't matter. The concepts are going to be the same. So again, I'm not going to dwell on the React side. I just think React is kind of a good visual representation when it comes to talking about volumes, and that's why I chose it. But again, don't dwell on not knowing React. Again, we are focusing on how we can relate volumes to React and not looking at how we can code up a React application. All right, so let's go to our starter file, and over here we have our React application. So let's actually go about Dockerizing this thing. So remember, when we want to Dockerize an app, we have to first, well, create a Docker file. So the first thing that we have to do is we have to specify our base image. Now, what base image is needed for our React application? Well, to do this, you can either, well, know it from prior experience, or you can Google it up. So you can write React app Dockerfile. So you can say React app Dockerfile, and then you can click on one of the links, and then you can see here that the base image that they're using is Node, and they're using this specific version of Node. I won't use this version. I'm going to use just the typical Node Alpine version. But it seems like, well, we need the Node base image. So we're going to do Node Alpine. And then everything else is pretty much going to be the same. So let's actually pull up the Docker file that we had in over here. So we are also going to specify our working directory. We're also going to copy the package.json and then dot. Then we're also going to do an npm install, copy dot, and then we're going to do an npm run start. And I believe that is the command for a typical React application. So if we go to start here, we go to package.json, you can see that in these script tags we have start, and this is how we start our React app. So we can pretty much just copy this over here. It is the exact same Docker file. So there we go. We can copy that in. And now let's actually go about building this Docker file. So let's ensure that we are in basically the start directory in the O2 working with volumes. So let's go here and let's do cd O2 working with volumes, and then we are going to go cd start, and then we are going to do a docker build dot, and we'll just give it a name of React app. So that's what we're going to call our image. So now when we execute this, everything seems to be working fine. It might take a while. The npm install in this case is going to take quite a bit because React is quite a large application. And so you can actually see how it's going to pay dividends to kind of have the copy package.json first, and then the run npm install, and then the copy ... so that every single time we make a small change to our React application, we don't have to do the whole run npm install, and instead we basically can just use the cached version. Now, of course, if we install some sort of dependency inside of our React application, then that will change the package.json, and thus we can't use the cached version for this, and then thus we also can't use the cached version for anything below it. So you can see here it is taking quite a bit of time. I might pause the video, but I think we are almost done. So let's wait a little bit. Let's wait. Hopefully, please. I don't want to pause the video. No, I don't want to pause the video. All right. So we will just wait this out for a little bit. But once this React application is built out, we should see it inside of we should see it right over here inside of our images. So remember, we are just building the images. So I don't know if I can stall any longer. Let's see. I really don't want to stop the video. There we go. It seems like it is done. We are done the npm install. Now we're doing the copying, and now we just have to do, after we're done the copying, this is a relatively large step as well because the React application is pretty large. So once we are done that, I'm just going to wait it out for a bit. You can just talk and talk. You can probably just skip this part if you can. There we go. Finally. Okay, awesome. I managed to get through without having to basically stop the video. So over here you can see that we have our image, our React app image. So now what we can do is we can do something like Docker images. We can also see that in there. So let's actually run a container. Let's run that container, and let's actually see it in our browser. Remember, to do that, we need to do port mapping. So what we can do is we will do Docker run, and we will specify the image that we basically want to create our container from, so the React app. And then what we shall do is we're going to run it in -it mode. And this is actually a requirement if we want to run our React application. So this is basically in interactive mode. So this is pretty much a requirement. We can't do it in detached mode, unfortunately. And then we are also, let's give this container a name of React container. And we're also going to do a little bit of port mapping. So -p. And so what we are going to do is we are going to map the port 3000 from our browser. So 3000 from our browser to the port 3000 inside of the container. Now, how do I know that inside the container it is going to run on port 3000? Well, the React application by default runs on port 3000. So we are going to map in our local machine port 3000 to the container of port 3000. Now we don't have to, we can basically match a different port. We can basically match port 5000 to port 3000. And then in our local machine, essentially what will happen is something like this. We'll make a request to port 5000 and it's going to forward it to port 3000 on our local machine. But it is common convention to do 3000 and then 3000. That way, it's just a little less kind of, a little less headache, a little less confusion that can go on. So let's actually run this container. So let's go about doing that. This shouldn't take too long, and as you can see, well, we're getting some kind of React strips going. Okay, starting the development server. And if we go, let's actually go to localhost 3000. There we go. We have our React application, and this application is running inside of the container, which is awesome possum. So that is great. We Dockerized our React app. Now there's a little bit of a problem that might occur during development, and we are going to discuss that in the next section. So now that we are running the React application inside of our container, the next logical step is to start making some changes to our React application so, well, it can suit the needs of the app that we are trying to build. So let's actually go about doing that. Now, when we do that, we will notice a very big problem that occurs due to us running our app in the container rather than running it locally. So let's actually go about making a change. Let's actually just change the text of this link tag over here to something like learn Angular instead of learn React. Now to do this, let us go to the file where that text is contained. In React, this will be in the source directory, and then inside of the source directory, the app.js file. So let us quickly make a change to this. So we're going to change this from learn React to learn Angular. So let's do learn Angular, and then when we save this, let us go back to our application and let us do a quick refresh. Now when we refresh, notice that nothing has changed. And that is the main issue that we are facing right now. Whenever we make a change, none of the changes are reflective in the app that we are running. And this is bad because, well, we want to see these changes just to see if we are on the right track or not. It is a very, very hard development process if we can't see any of the changes. Now, why is this happening? Well, there's actually a very good reason why this is happening. And let's actually look at a diagram to understand why. So let's look at a diagram. So over here, we have our application inside of our local machine. So this would represent this over here. Now, before we changed it to learn Angular, it was learn React. So let's just change that back to learn React. And let's just quickly save it. So this right here is our application. Of course, it contains all the files and folders, but we are just going to simply focus on the app.js file. So initially, it was learn React. And then what we did was we created a Docker file for this specific application. And then we built an image using that Docker file. Now remember, in the image, we use that copy ... command. So what we do is we copy everything in the root directory of our application into the working directory of the image. Now at the time that we created the image, it was learn React. And so the image is going to have learn React inside of its app.js file. And then whenever we run an instance, a container off of that image, that will also be learn React. So what happens when we decide to change this to learn React to learn Angular? So we change this to learn Angular in our local machine, but that is not reflective of the image that we've already built. Remember, the React app image contains learn React. It doesn't matter what we change over here because we've already built out our image. And then when we run this image again, it will still be learn React. So if we want to change this, we would have to do something like this. We would have to change our code over here, and then we would have to rebuild the image. So we would have to rebuild the image. In that case, it would copy learn Angular, and then when we run an instance, a container off that image, then that would be learn Angular. Now, as you can imagine, this is probably not the set of steps that we want to take because it is very cumbersome and long, and it takes a long time for us to see the process. We would have to rebuild our image every single time we make a change to be able to see it. Let's actually go through this process just to show you how long it would take, and then in the next lecture, we will look at a better solution. Okay, so let's do that right now. Let's change this to learn Angular. So we're going to change this to learn Angular, and I'm just going to quickly just get rid of this and just stop running the container. Now what I'm going to do is I'm going to quickly build this image out again with this change over here. So I'm going to do Docker build, and I'm going to call this React app, similarly like what we called it before. So Docker build, we're going to call that React app. And I believe that is it. That's really all we need. So let's actually go about building this. It should be a relatively quick build because we're caching all of our stuff. And then we are just going to do a Docker run. So over here, let's just do a Docker run. We're just going to call this React Container 2 because I believe React Container already exists. We haven't removed it, so it shouldn't work. Now let's go about running this. Hopefully it doesn't take too long. Stalling. Let's refresh this for a second. There we go. Starting the development server. It should be up in a second or two. And there we go. It is up. And there you go. It says learn Angular. Now the reason why we did this is because we made the change. And then what we did was we rebuilt the image and then we ran the container off of that image. And because we rebuilt the image, we copied all the changes that we made in our app.js file into that image. Now let's say we made a mistake. We were like, you know what? Learn view. That's what we were supposed to say. Now if we save this and we go back, well, of course, nothing changes. We have to go ahead and rebuild our image and then rerun the container. And as you can imagine, this process is very cumbersome, takes very long, and there's actually a much better solution. And we will talk about that in the next lecture. So we can actually solve this problem with something known as volumes. And with volumes, we can basically map the directory inside of our local machine to the working directory of the container. And to explain this, let's look at a diagram. So over here, we have the app inside of our local machine. So basically corresponding to this app over here. And this in red is basically the directory that we are going to map into the working directory of the container. So basically, this is going to be the start directory right over here, everything inside of the start folder. So essentially what we want to do is we are going to map this start directory into the working directory of the container. And that way, when we make a change to this, so let's say we add another file, let's say a nav.js file. When we make a change to this directory, it will be reflective on the working directory in our running machine. So let's quickly go over here. Let's do nav.js. And then that will also cause a change inside of the working directory of our running container. Now, if we deleted this, well, that will also be reflective inside of the working directory of our container. And if we made any sort of change to the files inside of this directory, it will also change inside of the running container. For instance, if we basically made a change from learn Vue to learn React, that will also change inside of this working directory. And thus we will be able to see all the changes in real time, which is exactly what we want. We don't want to go through that rebuilding an image and then running a container off that image process. That is too much of a hassle. So how do we achieve this? How do we achieve this mapping over here? Well, again, we achieve it with volumes, and we can specify volumes in the docker run command. And it will look a little something like this over here. So here we have the -v flag. So this is basically indicating that we are creating a volume. And then the first part is going to be the absolute path to the directory that we want to map into the container. And so this path is going to be the absolute path to this directory right over here. And we can simply get that by just right-clicking and saying copy path. And then if we go over here, we can basically paste that path right in there, and you can see that's the path. That's the absolute path to this directory. Now over here, this is going to be the path to the working directory inside of the container. This one is very easy because, well, we specified that inside of our Docker file. So that is pretty much it. We're saying that we want to map this directory into this working directory inside of the container. And that way, if we make any sort of changes inside of this directory, it will be reflective inside of the container. Awesome. Now, if you are on Mac, there is a little bit of a shortcut. So instead of having all of this, what you can do is something like PWD. So $PWD. And that basically achieves the absolute same thing. Essentially, if you are already in the start directory, so let's actually go about doing that right now. Let's actually go to the start directory. So we can do CD, then O2, working with volumes, and then start. If you do PWD and then enter, you get the same exact path. So basically, if you do $and then brackets PWD, you're achieving essentially the same thing. That's just a little bit of a shortcut. So that is awesome. So that seems to work, but there is a little bit of a problem with this approach. And let's actually take a look at another diagram to kind of explain this. So right now in our application, in this folder, we don't have any of the node modules because we never did an npm install. Now remember, when we build our image, we do the npm install inside of that image. And that's why we have the node modules inside of that image, and thus that's why we would have it inside of the container. So it doesn't matter if we have it in this folder right over here. So let's say before we do any kind of volume mapping, our container can look something like this. However, if we do decide to do the volume mapping and we haven't installed all the dependencies for our React application, and thus we're missing the node modules, well, this mapping is going to cause the node modules to go away inside of our container as well. And that is terrible. That is not what we want. That is not going to allow our application to run in the container because we need those dependencies. So essentially, we somehow, some way, we want to say, okay, well, we want to have this kind of mapping, but we want to leave the node modules completely alone. And well, we can do that with another volume. This volume over here, and this is known as an anonymous volume. So as you can see here, we don't have a path to our directory in our local machine. We are right away starting with the path to the working directory inside of the container. So for example, we don't have something here and then we have colon. Instead, we are just right away starting with the working directory inside of the container. And essentially with this, we are saying that, hey, leave the node modules alone. So inside the user app node modules folder, leave that alone. Do not touch it. We don't want any sort of mapping. If it's there, just leave it alone. And this ensures that, well, we can have, let's go back over here. This basically ensures that our node modules stay the same. And then because we still have this mapping over here that we specified, essentially any changes that we make over here will also reflect on the changes here, but again, we will keep the node modules. All right, awesome. So this is terrific. Let's actually go about running the container with these volumes. Okay, so let's go and stop this instance right over here. And then we are going to do a Docker run, and let's just say React app, because this is the image that we are trying to run. Let's also give this a name of React container with volumes. And then we're also going to add that IT flag, of course. And we're going to do some port mapping. So port 3000, port 3000. And then over here, I mean, the flags, they don't matter the order where you put them. So I'm just going to put them right over here so we can see them. So I'm going to first add that first volume that maps this directory to the working directory of the container. So that is going to be, you can either copy the absolute path, but I'm going to use basically this shortcut right over here, just because it is a little faster. Now, if you're on Windows, you're probably going to have to use this over here. If you're on Mac, this is just a much quicker shortcut. So we could just, I'm just going to go ahead and just copy this over here. So I'm going to basically specify, the working or the absolute path of the directory inside of our application. And then we are going to specify the working directory, and that is going to be well, slash user slash app. All right, awesome. So it is looking exactly like this. And now what we want to do is we want to add that anonymous volume. So we want to add that anonymous volume. So then we are going to specify another v tag, and then we're going to go to the basically the directory right in the container, the working directory. And we're going to say, hey, do not touch the node modules. All right, so let us go about running this. So let's run this. Now, this might take a little longer to run. So what I'm going to do is I'm just going to pause this video, and then once it runs, I am going to come back and just show you the changes that are made. Okay, after I celebrated 3 birthdays, this has finally decided to run. So now what we can do is we can actually go to localhost 3000, give it a quick refresh, and there we go. We see Learn View. Now let's actually go about making another change. So let's make a change. Let's change this back to Learn React. You can notice, you can see a quick compile, which is, well, that's a good sign. And there we go. Now we can see our changes in runtime, which is terrific. And we accomplished this with volumes. So I hope this kind of lecture gives you a clear idea of the importance of volumes when dealing with Docker. Okay everybody, welcome to the last project of this crash course. This project is O3 multi-container projects. As usual, I have a start and a final and a start directory. So if you go to the start directory, you will see another 2 directories, the client and a server directory. The client is basically a React application like the one that we saw a project ago. So that is that. And the server is an Express application like the one that we saw 2 projects ago. So let's actually open up VS Code and let's take a closer look at these folders. Let's look at our server first. And inside of the server, all we have is an index.js file and some package.json files. So inside of the index.js file, very simple Express application. All we are doing here is we are listening to one route. So if you perform a get route with this path over here to this server, all we are going to do is we are going to send back an array of objects. And what are these objects? Well, these objects are just objects that contain a name that is a string and a URL that is also a string that leads to a URL to a Google image. That is that, very simple. And then over here, we are just listening on port 5000. So I actually have this running at the moment. So you can see here, if you go to localhost 5000, that's basically the same as doing that GET request to just the slash path. We get our data back. So let's just quickly zoom in. Over here, you can see an array of objects, exactly the same as the array of objects we have over here. All right, so let's just zoom right back out and let's take a look at our React application. So again, very simple React application. Let's just look at the app.js file. This is just a little bit different. I got rid of all the boilerplate that we got in our React application when we first created it. Simply all I'm doing here is I'm using this useEffect hook to call this function when this app component is mounted. So as soon as this app component is mounted, I am calling this function called fetchPlayers. And what this function is doing is making a request to our server at localhost 5000. And because I'm not specifying a path over here, it basically assumes just the normal slash path right here. So basically I'm making a request to this route right over here. And so if I make a request to this route, well, I get back this data. And essentially what I'm doing is I'm storing that data in this component state. So I'm using set state over here. And then I'm iterating over that data. And then for each object, I am generating a card with that image and the name itself. So ultimately, if we run our React application, it should look a little something like this. So over here we have 3 players, their image, and the name. And if you don't know these players, these are some of the greatest players of all time. These are just NBA players. We got Timothy Luwalu-Cabarrot, Austin Rivers, and Dylan Brooks. So this is just a very simple application. We got a client that is making a request to our server. Our server is then sending data to the client, and the client is rendering this application. So how do we containerize this application? Well, let's look at a quick diagram. So over here, thus far we have been dealing with just one app, and we've been containerizing that application itself. Right now, we really have 2 applications. We got our server and we got our client. So to containerize this application, well, we have to create an image for our client. So this is the client image. Similarly, we're going to have to create an image for our server. So as you can imagine, we're going to have 2 Docker files for these apps over here. And then from these images, we are going to run a container. So here we have the client container, and then here we have the server container. And of course, when we run these containers, we have to do a lot of configuration. We have to do port mapping, volume mapping, and everything of that nature. So that is basically what we are going to containerize. We are going to containerize this application the way that we have been containerizing our applications throughout this crash course. So we are going to build out a Docker file, we're going to build out the image, and then we're going to manually run the container. And then after we do this, we are going to find a much better approach of managing these multi-Docker or multi-container applications. So we're just going to do it the way that we've already been doing it, and then we're going to do it the much better way using Docker Compose. So let's move on to the next section where we will containerize this application the way that we've originally been doing it. I'll see you then. So let's go about Dockerizing our application. So the first thing we're going to do is we're going to Dockerize our client. Now, of course, we would need to create a Docker file to do this. Now, the Docker file, we are going to do pretty much the same thing that we did with our last project. We're going to specify node alpine as our node image. Our working directory is going to be /user/app. Very simple. And then we are going to copy the package.json. So we're going to do package.json, and then we're going to copy that into our working directory inside of the container. Then we are going to do run npm install. It's very simple. We've done all these things before. Copy ... and then the command that we are going to execute when we run a container is npm run and then start. Very, very simple. We've done this before. So let's actually go to our client directory. So we're going to go to the client directory, and we're going to go ahead and build this image. So let's do a very quick docker build and then dot, and let's give this a name of let's say MBA client. Very simple. Let's go ahead and build this. This should be a relatively fast build for me because I am caching all of my stuff. I've done this build before, but for you guys it might take quite a bit of time, so just pause the video and if you're following along and wait until this is done. So now we can go ahead and run this container. So let's go ahead and run it. So we'll do a docker run, and this is called MBA client. Now we're going to do quite a bit of configuration. So we're going to do the -- name. So we're going to give this a name of simply just client. That's what we're going to call our container. Let's give it a volume of our current working directory. So we can do that with pwd, or you can just simply right click on the directory and copy path. This gets us the absolute path to this directory. So this is the volume that we are going to specify, and we're going to specify it inside of the working directory in our container. So that is that. And then let's also specify another volume. This is just going to be an anonymous volume telling it, hey, just leave the node modules alone. So there is that. So we got the node modules. And so one more thing, I believe we are missing the port. So let's expose port 3000 on our machine. So we're going to redirect that to port 3000 on the container. And also, because this is a React application, let's do it in interactive mode. So I believe that should be it. So let's go ahead and run this. I have an extra space. It shouldn't matter, but let's just get rid of that extra space. Let's go ahead and run this. And in the meanwhile, let's do the same thing with the server. So let's open up a new terminal. And it just so happens that the Docker file for the server is exactly the same. We're using the node alpine, we're specifying this working directory, we're doing these two commands over here, and the script is exactly the same, npm run start. So might as well just copy that and go over here. Let's create a Docker file, and then let's go ahead and do this. So it's exactly the same. Let's move into that directory, to the server directory. Let's go ahead and build this. So we're going to do a Docker build. And we're going to do a Docker build with, we're going to tag it MBA server, and we're going to do dot at the very end. So there we go. That is that. That should be a very quick one for me and relatively quick for you because the dependencies are very small. Okay, so that is that. And now we will just quickly run this. So we'll do a Docker run, and now we're going to have to specify all these things again, the ports and the volumes and everything else in that nature. Now, as you can imagine, this can get very tedious, especially if we have a relatively large application with multiple images and multiple containers that need to run. Doing this by hand is very, very tedious, and this is exactly why I'm going through this, because there's actually a much better solution that we are going to do in the next section. So let's do a quick port mapping. So we'll do port 5000, 5000. Let's give it a -- name. Let's call it server. And then we are going to do the volumes. So the volumes, we're going to do our current working directory into the, or our current directory into the working directory of the container. We're also going to specify the, anonymous volume, telling it, hey, just don't touch our node modules. I believe that should be it. We're exposing the ports. We have all the name. We have our volumes. That should be fine. I think the last thing is just to specify the image, which is the MBA server. Again, you can see how tedious this gets and maybe how error prone this can get. This over here, you know, we can very easily miss something. So let's go ahead and execute this. Hopefully this runs perfectly. Let's see if the React application. So it seems like the React application is up and running, which is terrific. And okay, so it seems that our server is up and running. So now let's actually just test it out. We can refresh. Let's refresh the server. Just refresh this. Perfect. Seems fine. Now let's go to our React app. Okay. So this seems great. It seems like it works perfectly fine. However, you know, this was kind of a hassle to do. Imagine, now, this was a hassle with just 2 images. Imagine if you have more images than this. Like, we have to write a Docker file for each image. This is a given. We're going to have to do this regardless. But then for each one, we're going to have to build the Docker file. And then for each one, we have to run a container with all of the specifications. This gets very, very tedious very quickly, and it is not error prone. We can get multiple errors throughout this application, especially if each container needs to run in a different way. We have different configurations for each container. Over here, we have pretty much the same, but again, with larger applications, these containers might have to run in different ways. So this is very, very, very tedious. Again, we have to build the image and run the container, and then when we're done with the container, we have to shut down the container. We have to do everything by hand every single time. And so there's actually a better solution to this. And this solution is known as Docker Compose. Essentially, with Docker Compose, we can put all of the configuration into one file. How to build the image and how to run the container. Everything. And this is not just for one image in one container. We can put multiple images. All the images that need to run for our application to run, we can put all that configuration in one file and basically execute that one file with one simple command. and then that file will automatically create all of the images that it needs to create and then run containers right off of them and have these containers interact with one another. Again, we do this with Docker Compose. So let's actually do that in the next section. So far, when we wanted to containerize our application, these were the steps that we took. First of all, we created a Dockerfile. Off of that Dockerfile, we built an image, and then off of that image, we ran a container. And over here, we manually specified all of the kind of configuration that we want when running that container. Now, we actually saw that at least these two steps were very, very tedious. And we only did this with 2 containers. Imagine if we had an application that had hundreds of containers or even 10 containers. Having to do these steps that many times is very, very tedious and very, very error prone. So what we can do instead is, if we have an application that has multiple containers, we can specify all of these configurations, the build configurations and the run configurations, all in a file. And we can do it for multiple images. So we can put all the images and all of the kind of container configurations inside of one file. And then we can execute one command, and it will automatically build and run our containers for us using the configuration that we put into that file. So that way we only have to do the configuration once, and basically then we can just simply do a kind of a Docker command and it will run it for us. And if we need to make any sort of modifications, we can easily do that within the file itself. Now, what is the file that we can do this with? Well, it is known as a Docker Compose file. So let's actually go about doing that right now. So remember, last time what we did was we ran our application by doing these 2 steps over here. We built out our image manually and we ran our container manually. Now we are going to run our application by putting all of those configurations in a Docker Compose file, and then we're going to run that Docker Compose file, and it is automatically going to build our image and run our container. Now, to do this, the first thing that we have to do is we have to go to the directory that we are working with. This is going to be the start directory. And then in that start directory, notice, not in the client, not in the server, we are going to create a docker-compose.yaml file. And you can see here we have this kind of pink Docker logo right over here. So this is where we are going to write all of the configurations to build our images and run our containers. So the first thing that we have to do in here is we have to specify the version of Docker Compose that we want to use. So the version of Docker Compose that is the most recent for me at the time of this recording is 3.8. So I'm going to use 3.8. Next, we want to specify the services that we are going to use, and basically these services are going to be the images themselves and then the containers that run off of those images. So we have 2 services, the client service and then the server service. Again, the service is going to contain the information as to how to build this image and then how to run a container off of that image. So over here we have to specify services. So we do services and then colon, and then basically we want to go inside of the services. So we do this by having a tab, and then in here we're going to specify all of the services and the configuration. So the first service that we want to create is MBA client. Okay, so this is just the client service. So the first thing that I want to tell it is, well, I want to tell it how we can build our image. So before I say that, if you're not familiar with YAML, the spacing is very, very important. As you can see here, this is services, and then because I have 2 spaces below services, it's basically interpreted that this MBA client is within this service line right over here. So the spacing is very, very important. So over here we have the MBA client service, and I want to basically specify how we can build the image for this service. Well, to do that, we would say build. Again, notice the spacing indicating that, hey, this is basically a child of this over here. So we specify build, and then another tab, and then we want to specify exactly where the Docker file lies. So right now we are in the root directory, in the start directory right here. The Dockerfile is right inside of the client directory. So we have to tell it that, hey, the Dockerfile is inside of this directory, the client directory. So use that Dockerfile to build out our image. So to do that, we use context. And then we specify the path of that directory. So we say, well, the client is in the client directory right over here. So again, we are starting off in this start directory. You can just move into the client, and that is the Docker file. The next thing that we have to specify is, well, Dockerfile. And this may seem a little bit weird, but what this basically means is, well, okay, go into the client directory, this is the context, and the Docker file, its name is called Dockerfile. And again, this may seem a little bit strange to you, but it's also highly likely that we can have multiple different Docker files in there with multiple different names. For instance, maybe we have a production Docker file called Dockerfile, and then maybe we also have a Dockerfile.dev Docker file, right? So we could also have a Dockerfile.dev Docker file. Maybe for development, we want to use that Dockerfile.dev Docker file. So essentially in here, what we would say, well, Dockerfile.dev. Now in this case, this Dockerfile.dev is completely empty, so I'm gonna want to use this Docker file. But again, over here, we're specifying that, okay, inside of this client directory, the Docker file that I want you to use to build this image is, well, this Docker file and not this Docker file. And again, if I wanted to use this Docker file, well, I can use Dockerfile.dev instead. Again, it seems kind of, it doesn't seem kind of needed if we only have one image, but again, with more production scale applications, we might have multiple Docker files in a directory. So I'm just going to quickly delete that, move it to the trash. So that is the build. This is basically how we are going to build our image. Now we have to specify, well, how are we going to run our container? So let's say, well, the first configuration is going to be container name. And again, the order of these configurations doesn't matter. We can have container name up here, build up here, but this is just the order that I like. So basically, when I want to run a container over here, this is basically saying, hey, what's the name of the container that you want to run? So this is basically the same as this right over here, this step. Now I'm going to say I want to call this container, let's call it just plain old, well, client, not server. I'm just going to call it client. I'm just going to call it client, let's say Docker Compose, just so we can have a more of a unique name. Okay, so that is that. And then we want to, again, continuously specify these commands over here. Let's specify the ports now. So let's go over here and let's say ports, if you want to specify the ports. Now we can have multiple port mappings, and therefore this is going to be an array. Now in a YAML file, we specify an array with the dash, but in this case, we are going to use one. So over here, we're going to say, well, we want to map port 30 or 3000 in our local machine to 3000 in the container that we are running. Now, if you wanted more port mapping, for instance, let's say we wanted, 3001, we can do this as well. And that now basically port 3000 and 3001 are in our local machine is mapped to port 3000 in our container. Now I don't want to do that, so let's get rid of that, but this is basically what that kind of array is symbolizing. So that is ports. So let us do volumes now. So to do this, we will do volumes. And volumes, very simple, is also going to be an array. As you can imagine, we can have multiple volumes. So as you can see here, this is one volume and this is another volume. In this case, we are going to use multiple volumes. So the first volume that we are going to specify is kind of that volume that links the our directory to the working directory of the running container. So that is going to be dash client. So we don't need to use like an absolute directory in this case. We can just move into the directory that we want to use. So we do /client, and then we say, well, go into the user or the working directory inside of our container. So that's the first volume. Let's do the anonymous volume. So this is going to be just an anonymous volume /user/app/node modules. basically indicating that, hey, hey, just don't touch the node modules, leave them there. So that is that. So the next step is, I believe that is it. One special configuration that we need for a React application is this one over here. So environment, and then environment, we have to say Chowkidar use polling. So use polling and then true. Basically, this is needed only for, I mean, maybe some other images would need this, but this is needed for the React application because React uses Chowkidar software to kind of watch for files. So this is needed. This kind of environment over here is needed. There's always some edge cases with different frameworks. You're going to probably have to read certain documentations to figure out what is needed and what isn't. But this is just typical for a React application. Okay. So that is the service for the kind of the client image, the MBA client image. Okay, so that is awesome. Let us do the exact same thing, but for the server image. So as you can see here, I moved back right over here in this line, basically symbolizing that I'm outside of the MBA client. And now over here, I'm going to do MBA, and then I'm going to call this MBA server. Over here, we're going to do pretty much the exact same thing. We're going to specify where we can build this image. So we can do build, and we can do context, and let's do -server. And then we'll say that the Docker file, well, it's called Dockerfile. I believe I have an extra spacing there. Let's get rid of that. Now let's specify the container name. We will say that the container name, let's see, we're just going to call it server Docker compose. And then we are going to do the ports. So we can have multiple ports again, but we're just going to use one, port 5000 to port 5000. Awesome. And then the volumes, I'm just going to go ahead and copy the volumes. They're going to be exactly the same. So let's just copy these volumes. I lied, they're not going to be exactly the same. We're going to have to map the server directory, not the client directory, but other than that, it's going to be the same. And I believe that is pretty much it. Let's also add this to our server. This might not be needed for our server, but just to be safe, I'm just going to add it in there. It worked for me last time. So there we go. Now what we did is, instead of writing all of these configurations all over again inside of our terminal, we specified all of the configurations into this file. And now if we want to basically execute those configurations, all we have to do is tell Docker, hey, use this file, interpret this file, and execute the configurations that I've specified here. So let's actually quickly go to my Docker desktop. Let me see if I can increase the size of this some more. Let me see if I can actually zoom in. It doesn't seem that way. So let's go to Docker desktop. I'm just going to quickly get rid of these containers. And I'm also going to quickly get rid of these images. So let's do that. Just so that we don't have these images kind of hanging. I just want to quickly show you how it's going to look after we execute that file. So all those images are pretty much gone. I think the only ones that are remaining is the ones that pertain to Kubernetes. So how do we execute this? Well, we need to use our terminal one more time. So we can just go over here, we can go terminal, new terminal, and simply we move into the directory where the Docker compose lies. So we go to O3 and then and then starter or start. And then in here, to execute this, all we have to do, let me just double check that my images and containers are gone. Okay, it seems that way. So all we have to do in this case is one command, docker-compose and then up. And basically what this does is it builds our image and then right away runs the container using the configurations that we have specified. So if we do that, docker compose up, and we wait a little bit. So it says here, it also creates a default network for us, which allows us to easily communicate between the MBA client image and the or MBA client and the MBA server image. And you can see here now, it's basically building out our Docker file, which is cool. So that's something that we are not doing anymore. So you can see that that's happening. Hopefully this doesn't take too long. So okay, so you can see here now it's doing all the working directories, doing all the copy, doing an npm run install. So it's doing all of these steps for us, which is terrific. So this actually might take a little bit of time. So what I'm going to do is I'm going to just pause this video and I will be back once this is done. And by the end of it, you should see something that looks a little like this. So over here, you can see our server container that is running. So that's server Docker compose. That's go ahead and running. We can see here that it says listening on port 5000. And then over here, we also see our client container running. This is the client Docker compose. And that's also working, and it's listening on port 3000. Now if we go ahead, we can actually see it right over here. So I went ahead and opened it. We can refresh. So you can see that both our client and our server are running really well inside of the container. And because we specified all of the volumes, we can actually go right ahead. Let's go to the client and let's make a quick change. Let's say over here, instead of just having the bodies, let's have a quick title. And let's just say H1 best MBA players of all time. And then we can save that. And you can see here, it quickly recompiled. Now if we go back, we can see that it's not very pretty, but it is there. And there we go. Everything that we did is, well, there. All the configuration that we've specified is inside of our Docker file or Docker compose YAML file. So now if we want to run up this application again, we don't have to go through that process anymore. All we have to do is a Docker compose up, and it is going to use these configurations to build our image and run our container. And if you go to Docker desktop, you can see here start, this weird start container, and you can actually open up the start container, and it basically shows you all of the containers that are running from our Docker compose. So you can see here our server Docker compose and then our client Docker compose. Now let's say we want to kind of just shut everything down. Well, how do we do this? Before, what we had to do was we had to stop the containers and then remove them. So that's just kind of a two-step process for each container. So this can get very, very tedious. If we wanted to do that with this, well, we can just basically stop this, and then we can do a Docker compose down. So when we stopped it, what it did is it basically exited the containers, but they're still there. What if we don't want them there anymore? We can just say Docker compose down, and it basically just removes the containers for us. So there you go, and that is that. And that pretty much concludes the last lecture of this crash course. I'm going to have kind of a spiel at the very end, so if you want to listen to that, listen to that. But this is pretty much the end. Thank you for watching, and I'll see you in the next section, kind of the end statement section, if you will. Bye-bye.